Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, my today's topic of the lecture is the law of conservation of mass. It's one of the laws of the chemical combination. They are total four in number, and it's the first one, the law of conservation of mass. Let us discuss what's the law of conservation of mass. The law of conservation of mass states that mass can neither be created nor destroyed, although it can be converted from one form to another. We are dealing with chemical combinations. So, in terms of chemistry, the law of conservation of mass states that during any chemical reaction, during any chemical reaction, the total mass of reactants is always equal to the total mass of products. Let me correct one term. During any chemical reaction, that chemical reaction should be balanced. So let me take an example for you. As an example, I'm taking the reaction of combustion of methane gas. What's methane? Methane is CH4. During combustion or burning, the combustion is always supported by oxygen gas. When any hydrocarbon burn in oxygen, it always produces carbon dioxide and water. Here, the next step is to balance this chemical reaction. We are having one carbon, we are having one carbon. Here we are having four hydrogen, but here we are having only two hydrogen. So we have to multiply whole term by 2. It's 2H2O now. So let's count oxygen in products. Oxygen in products are now 2 oxygen and 2 oxygen. Total of 4 oxygen. That means we have to apply a stoichiometric coefficient of 2 over here to make the 4 oxygen atoms on the reactant side. So in a balanced chemical equation, you have equal number of any type of atom on the both sides, that is the reactants and the products. So in this chemical reaction, we are having one carbon on both sides, four hydrogen on both sides, and four oxygen on both sides. So that's my balanced chemical reaction. So let us calculate its masses. The masses, first of all, the mass of methane. The mass of carbon atom is 12. The mass of hydrogen atom is 1. But it's 4 our number, so we have to multiply it with 4. The total mass comes out to be 16 grams for methane. Let's talk about oxygen atom. The one oxygen atom has 16 gram weight, 16 gram or 16 AMU. AMU stands for atomic mass unit. We just simply write 16 grams. Now oxygen are total 2 in number 2, but we are having also stoichiometry 2, so we have to take it like complete 2. So it comes out to be 16 to the 32. 32 It's 32 into 2 comes out to be 64. 64 grams. So here I am now calculating total mass of reactants. The total mass of reactants comes out to be 16, that's of methane, and 64 AMU, that's of oxygen. And the total mass comes out to be 80 grams. We are having net of 80 gram reactants. Now let's talk about the product side. So first of all is carbon dioxide. The mass of carbon atom is 12, mass of oxygen atom is 16, and 16 into 2 because oxygen are 2 in number. The mass of CO2 comes out to be 44 grams. Now, now let's talk about water. The mass of one hydrogen atom is 1. Hydrogen are 2 in number, plus the mass of oxygen atom is 16. So it comes out to be 18 grams. But again, here water are 2 molecules. So we have to multiply whole term with 2. It comes out to be 2 into 18. 18 to the 36. So now I am calculating total mass of products. The total mass of products comes out to be 36 plus 44. Again it comes out to be 80. So here you can see that the law of conservation of mass is totally obeyed, as the total mass of reactant is equal to the total mass of products, that is the 80 grams and the 80 grams. So it proves the law of conservation of mass. So now let us attempt 5 numericals on this law. The first numerical that I have written for you. The question says that we are having 1.7 gram of silver nitrate. So let me write what silver nitrate. It's AgNO3. It is dissolved in 100 gram of water. After that, he is saying 0.585 gram of sodium chloride is dissolved in 100 gram of water. So I am taking sodium chloride NaCl. Now after that the question is saying when both these solutions are mixed, a chemical reaction occurs. So what's that the chemical reaction? Like AgNO3 plus NaCl. They reacts to form me AgCl plus NaNO3. So that's a double displacement reaction in which the Ag is displacing Na from NaCl and Na is displacing Ag from AgNO3. This type of reaction is called double displacement reaction, which we will study in detail in the further topics. So let us talk about the law of conservation of mass on this point. Then I'm coming back to question. When both the solutions are mixed, a chemical reaction occurs in which 1.435 gram of silver chloride and 0.85 gram of sodium nitrate is formed. So let me take an example. Let me take values of this. The silver nitrate is 1.7 grams. I'm writing 1.7 grams over here. It is reacted with 0.585 gram of NaCl. When both solutions are mixed, a chemical reaction occurs in which 1.435 gram of AgCl is formed and 0.85 gram of sodium nitrate is formed. Show that this chemical change follows the law of conservation of mass. That's the question. So, before solving anything, firstly we have to see, is our reaction balanced? So let us check. We are having 1 Ag on both sides. Okay. We are having 1 NO 3 negative ions on both sides. Yes. We are having 1 Na on both sides. Yes. And we are having 1 Cl on both sides. Yes. This reaction is totally balanced. So let us calculate uh, total mass of reactants. It comes out to be 1.7 grams plus 0.585 grams. So it comes out to be 1.7 plus 0.585. It comes out to be 2.285 grams. So let us talk about the products. Here I am writing total mass of products. It comes out to be 1.435 grams plus 0.85 grams. This answer comes out to be 2.285 grams. As we are getting equal masses of total reactants on products and the total mass of the reactants, we are getting equal masses of the reactants and the products on both sides. So it proves that the law of conservation of mass is obeyed in this reaction. Law of conservation of mass is obeyed in this reaction. So I'm done with my first numerical. So let us start with the another numerical. So in first numerical we have to prove that is the law of conservation of mass is getting obeyed in this reaction, as we got the equal mass of the reactants and the products. So yes, the law of conservation of mass is obeyed in this reaction. So now let us talk about the numerical number 2. What mass of sodium chloride would be decomposed by sulfuric acid? Let us take an first of all reaction sodium chloride. What's sodium chloride? It's NaCl. Would be decomposed by sulfuric acid. What's the sulfuric acid? It's H2SO4. Further, if 12 gram of sodium bisulfate is sodium NaHSO4. That's called sodium bisulfate, and this is the product of the reactant. And hydrogen chloride, that's HCl. So that's my chemical reaction. Let me check, is it a balanced chemical reaction? Yes, this is a balanced chemical reaction. So what's the exact numerical? What mass of sodium chloride would be decomposed? I have to find the weight of NaCl. Would be decomposed by 9.8 gram of sulfuric acid. 9.8 gram of sulfuric acid. If 12 gram of sodium bisulfate, if 12 gram of sodium bisulfate and 2.75 gram of hydrogen chloride were produced in the reaction. Important point in numerical, assuming that the law of conservation of mass is true for this reaction. That means total mass of reactants is equal to the total mass of products. So let us assume this weight to be x grams. So how will this question will go on further? Total mass of reactant is x grams plus 9.8 grams. It is equal to the 12 grams plus 2.75 grams. So my x comes out to be, it's 12 plus 2.75. This thing comes out to be 14.75. X plus 9.8. My x comes out to be 14.75 minus 9.8. It comes out to be 4.95 grams. So that's the mass of NaCl that was required. Like I'm mentioning some more things in this reaction, in this numerical, the total mass of reactants, that is the mass of NaCl plus the mass of H2SO4. The total mass of products, that's the mass of NaHSO4 and the mass of HCl. So here I come out, my answer comes out to be 4.95 grams. So I'm done with my second numerical. Now move to the third numerical. The third numerical is saying like if 6.3 gram of NaHCO3 is added to 15 gram of CH3COOH. I am writing the reaction NaHCO3 plus CH3COOH. The residue is found to weigh 18. The residue is found to weigh 18 gram. What is the mass of CO2 released in the reaction? So let me complete the reaction first. It's NaHCO3 and CH3COOH. That's an acid-base reaction. We come up with a salt, that's CH3COONA plus H2O plus CO2. That's my gas over here. So here in numerical, the residue comes out to be this thing. This whole thing is residue and this gas has escaped out. So in numerical, in question, we are having 6.3 grams of NaHCO3. We are having 15 grams of CH3COH. We are having 18 grams of total residue, and we have to evaluate the mass of CO2, that is, let it be x grams. So again, we are taking the law of mass action to be true for this reaction. So total mass of reactants, the total mass of reactant must be equal to the total mass of products. So what are reactants over here? The mass of NaHCO3 plus the mass of CH3COOH. It's 6.3 grams plus 15 grams. Here is my residue plus CO2. The residue comes out to be 18 grams. The mass of CO2 we are considering to be x grams. So my answer comes up with is 15 plus 6.3 is 21.3 grams minus 18 grams comes out to be x grams. minus 18 grams. My X grams comes out to be 3.3 grams. So the mass of CO2 produced comes out to be 3.3 grams. So I'm done with my third numerical. Hope you all got it very well. So I'm moving to my fourth numerical. Now, what the fourth numerical is saying, what amount of silver nitrate, I'm writing silver nitrate to be AgNO3, will react with 6.45 gram of NaCl. I'm writing this to be NaCl to produce 14.4 gram of silver chloride. Silver chloride, that is AgCl, and 7.9 gram of sodium nitrate. Sodium nitrate is uh, AgNO3. Before moving to any numerical, again we have to see, is this reaction balanced or not? We are having equal number of Ags on both sides. NaCl, yes, this reaction is totally balanced. Then question is, what amount of silver nitrate? What amount of silver nitrate? Silver nitrate is AgNO3. I have to evaluate this weight. Will react with 6.45 gram of NaCl. 6.45 grams of NaCl to produce 14.4 gram of silver chloride. To produce 14.4 gram of silver chloride and 7.9 gram of Ag sodium nitrate. 7.9 gram of sodium nitrate. I'm so sorry, sodium nitrate and NO3. This comes out to be 7.9 grams. So if the law of conservation of mass is true, so again, what's the law of conservation of mass? Total mass of reactants must be equal to the total mass of products. The total mass of reactants is the mass of AgNO3 plus the mass of NaCl must be equal to the mass of products, that is the mass of AgCl plus the mass of NaNO3. One thing more, if this numerical is coming in your subjective exams, in subjective exams you have to write the whole term, the mass of AgNO3 plus the mass of NaCl is like the mass of AgCl and the mass of NaNO3. You have to write complete. Now but in case of multiple choice questions, you can solve it directly in the rough. So what's the mass of AgNO3? Assume it to be the X grams that we have to evaluate. What's the mass of NaCl? It's 6.45. What's the mass of AgCl? It's 14.4. What's the mass of NaNO3? It's given to be 7.9. So let us evaluate. It's 14.4 plus 7.9 is 22.3. 22.3 is minus 6.45. Minus 6.45. It comes out to be, my X grams comes out to be 15.85 grams. So that was my fourth numerical. So now move on to the fifth numerical. That's the last for today. So in this numerical, he is again saying that 4.2 gram of NaHCO3 is my NaHCO3, and its weight is given to be 4.2 grams. Is added to a solution of CH3COOH. CH3COOH weighing 10 grams. So its weight is 10 grams. it is observed that 2.2 gram of CO2 is released. So what will be its product? What will be their products? It comes out to be CH3COONA plus H2O plus CO2. 2.2 gram of CO2 is released. So here the weight of CO2 is 2.2 gram. The residue is found to weigh 12 grams. Here he is taking these both products to be as residue. Residue because CO2 is a gas which will escape out and the residue is left. The residue weight he is saying to be 12 grams. Show that the reaction follows the law of conservation of mass. Here I have to prove, is this reaction following the law of conservation of mass? For that thing, I have to evaluate the total mass of reactants and the total mass of products. So here I am writing total mass of reactants. The total mass of reactants comes out to be obviously mass of NaHCO3 plus mass of CH3COOH. It is 4.2 grams, it is 10 grams, which comes out to be 14.2 grams. So let us talk about products. The total mass of products will be obviously the mass of here residue plus mass of CO2. The mass of residue here is 12 gram. The mass of CO2 is 2.2 grams. We have to add it up. That comes out to be 14.2 grams. Here again, we are having equal mass of reactants and equal mass of products. We are having the total mass of reactants to be equal to the total mass of products. Hence, this reaction follows the law of conservation of mass. This reaction is following it. So that's all for numericals of law of conservation of mass. Hope you all got all the numericals, how to solve them. I'm giving my phone number on the thumbnail of each and every video. If you are having some doubts, you can book an doubt session with me. So keep do like, subscribe and share my channel to the maximum extent, and please don't forgot to hit the subscribe button of my channel. Please do subscribe and please do share it to a maximum extent. Thank you.